but hey, this is the first time for everything, right? I guess we're gonna go back into opcode land today, or another new problem. Guess we shall see. Problem. Hey, we are back at opcode land. All right. Let's see here. That was the bad one. This parse code. Okay. Okay. Much thing, and we have negative numbers today. We did not have before. Not sure if that should be a problem. I'm using signed numbers for everything. Okay, so we need an opcode 3 and an opcode 4. Takes a single integer as input and saves it to the address given by its... Oh, wait, we have an input value. Take an input value and store it. Okay. Value stored with output the value of its only parameter. Output the value. Okay. Value stored at address 0. Output that. Okay. Parameter modes are values these opcode number base. Rightmost to value. Multiply instruction. Opcode 2. Okay, so we by mod 2. Mod 100. Not mod 2. Digits. Okay. Oof. Right, far. Let's see. Multiply. Hundreds digits and the thousands digit. Okay. That makes sense. 1010 100. Effectively, this will get us the modes of each parameter. And most time. Applies its parameters. Get mode is value 3. It's written in the third problem. Premise it right to instruction will never be in immediate mode, so I don't have to check for the right hand side. Okay. So it is. Oh. Modes again. Parameter mode. So then we're in position mode. Otherwise, we're in map mode. otherwise that mode. Yes. Similar, except they are location. Alright, so then back to our original thing. Take still don't have instructions, documentation, input and output. I still don't understand how input and output work. So I need to understand that before I can do. Okay. ID test input. Test what an output. For the diagnostics code, followed immediately by a halt. I have to be able to detect when it's a. So effectively, if this is not an I and we just output, I have to do some special testing with outputs, and then I have an input. So I'm going to have an input and output. Okay, so now I can go back to my instructions here. At a position 8. Okay, so its store instructions are always absolute. So store, so we're always storing at 3. Put. Okay, so now this one we have to make conditional. At and this one I think will take people a little bit longer. Either that or I'm just bad at it. Now does it go and I P9 breakpoint there. That section writes to will never be in mode. Value longer always were. Yeah, I think it says values, but then it refers to some of those parameters. I don't think it intends there to be a difference between them. I think they just mean, like, if we have one arg increment by 2, if we have one arg, we increment by 2. Okay, so that's a 1 output. I'll put all this. How far off are we? No output, all zeros, and that. Yes, rank 22. Nice. Okay. Comes online. Okay, so we need more opcodes. Let's take this here. Oh, here we go. Now we have our first conditional ones. These are fun. All right. So number's non-zero. It sets the instruction value to the value from the second parameter. Okay. Remember, we still have to do our mode things. So we're going to take one. So if 1, 0, direction pointer is that, else direction pointer add, see, we're not going to add 4, we're going to add 3 because we took 2 arguments. This was 5. Okay. Normally after instruction over the instruction modified the values used and is not automatically increased. Okay. So that's why we have to do these. So this is an equals 0. Okay. That. Okay, so if we're in 7. First parameter is less than the second parameter. Less than, not less than, or equal to. These 4. Oop, nope, we're not modifying the instruction pointer. Say if less than, it stores a 1 in the position given by the third parameter. Second. Equals 1. And I'm just going to do it repetitive, but I don't want to. Okay, so less than, it's 1. If it is 1, if it is equal, then it is 1, otherwise 0. 4, 4, 3, 3. Okay. Four. Six. Ours. Input. Input value is your setup as different things. Keep this commented out for the moment. Okay, so we'll try 8. Try 7. Try 8. 7. Try. Yeah, so we're just going to try 8 and 7 for every one of these. Just. I don't need help on ints. Not yet. Test 0, and we're 1. Test 0, 1. Okay. So if it is equal to 8, we're going to go 1, 0. If it is less than 8, we're going to go 0, 1. If it is equal to 8, we're going to go 1, 0, 0, 1. We're going to go output 0 if the input was 0, or 1 if it was, yep, those all look good. All right. Larger example here. Okay, so I did 8. So 7, 8. Output 99 if it's below 8. Take this, add it 5. Output a value. Oh, a 22 and a 35. Nice. Nice. Does that give me, that doesn't give, that's enough for a spot on the global board yet, right? No, not quite. 168. Wait, no, that's not enough. 79 plus 66, 145. I am not far off. 145. I'm almost on the board in 1 day. Ah. All right, so I mean, I could have saved a little bit of time because my algorithm basically worked first try, which is really odd. I don't know if you happen to be watching this and haven't watched any of my other ones. They've been a story of me tripping over myself, missing something simple, making a stupid mistake, or something else. But this parameter to code logic stuff, I think I could do better with that. Actually, be able to use, well, here, let me just commit this. So part of what I'm noticing here is, yeah, there's definite value. Parameter things. Let's see, I can't do, so mode will be I divided by 10 times 10 to mod 10. Effectively, this is, so if pnum is 1, this will evaluate to 100, right? 10 times 10. It's 2, it'll evaluate to 1,000, and so on. So effectively, this lets me get the parameter mode for a given thing. Then I can Don't need parameter modes for those. Well, it won't hurt to check it or to do it. Actually, I was just those in there, wasn't I? Yeah, I forgot to fix that one. Value. Get param and a set param, and now I don't need these anymore. Set or set by param. Cool. So, oh. Setting by param put. We're just gonna get by param 1 here. Get by 1. Get by 1. Set 3. 1. Oh, okay, so now I can simplify this. Quality. Alright, there we go. Way less code. And because these are declared here, so if I declared these out here, I'd have to pass I in. By declaring them in here, it's a new in C#. 5? I don't remember which version. We also could have done anonymous lambda thingamajigs. This is slightly less gross syntax for defining them. But if we run it again, we crash. Nice to know that I did it wrong. Method is not implemented at 9. Oh, we're hitting here. Did I miss a break? Not miss a break. First off, I don't turn. Yeah, again, too much JavaScript. Because that's probably the thing I did. I probably didn't actually. Oh. That is not the power operator, is it? That's XOR, isn't it? Yep, that is XOR. How? For some reason, I thought there was the shortcut operator for it, but apparently not. Turns out exponent and XOR are not the same thing. Convert this back int because math.pow only operates doubles. Actually, is that the double one that's using? Let's tell it to use. Wait, isn't there a decimal version? Convert from decimal to double. Is there not a? Oh. Huh. All right. Well, hopefully I don't lose precision and round off to the wrong integers. 99999. Let's check. What I got? 5. Yep. Okay. Cool. All right. So this works, and this will make extending more things simpler because now I've got the parameter fetching slightly genericized. Because I have a feeling we'll have a few more things to tack on here coming days. Yeah, this is more in the problem range that I do better at. So let's see. What is the? I assume the leaderboard is full. Cool. Leaderboard is full. So I got on at 10 minutes. See, I got on at the beginning, a little bit late in the wave. There's a couple of, man, these had 5 something. Yeah. The rest of us normal people start having a chance in the 8-minute mark, and I got in at 10, so that's not too bad. And it was still open for 15. And then, that's not what I was trying to do. And I got 35 for the second one. Again, pretty well into the masses. And I was about 6 minutes ahead of when it finished. All right. Anyway, this is, yeah, and we're about a half hour after I tinker with it. So yeah, this is like I think I've said a couple times. I don't do well at the ones where we're getting solves or the leaderboard just closing at like 5-6 minutes. These ones where it's 15-20 till it closes, I have a much better shot at making. But yeah, I did kind of get lucky in that everything basically worked. I will say I don't recall on problems like this before us getting this much good test data. A lot of times these problems rely on us not. There are things we can get wrong that you're not going to tell until you try it with your own inputs, and hence it's harder to bug because you're not sure what the exact right answer should be. It seems like we got clear things here, which is good. That is one thing I've had heard some people complain about is on these simulation style problems is sometimes a little hard to figure out where you went wrong if you went wrong. By providing us with this good of example data, we have a lot better chance of finding our own problems. I know one of the things that comes up is when we discuss these and people are having issues with it. Sometimes it's all about finding an input that's smaller than your failing one that you can debug easily. Yesterday there was one person who was having an issue. There was a certain kind of input. Once he found the input and was able to try it with it, it was obvious to him what was going wrong. He made a fix. He got it right. So yeah, there's just some. Yeah, I guess I'm torn. I guess I think it makes it more accessible. So I guess that probably makes it good. Plus, it keeps the solve times from getting crazy. So, which is one of the reasons I was unsure if I was actually going to try to leaderboard chase this year. But yeah, it's kind of fun. I could help myself after 2 days. Anyway, I guess I'm gonna call it a night.